here. So the first one we're going to do is we're going to graph together y equals 4 times the cosine of 6x. 4 times the cosine of 6x. And what we're going to do is we're going to graph one cycle of our function, which happens to be cosine right now. So there are two things that are happening here to this curve, right? Can anyone name the two things that are happening? Daniel, give me one of the things that are happening. And which one's the amplitude, the 4 or the 6? Yeah, the quattro. So this part right here means that I have an amplitude that's equal to the absolute value of 4, which of course is just 4. What is the period then? Well, it's not quite 6, right? Yeah, I take this and I take 2 pi divided by 6, which gives me pi over 3. So I have a period equal to pi over 3. So these are the two things that are happening, okay? Now, according to that handout that I gave you, we do phase shift first, then we do period, then we do amplitude, then we do vertical translation. So is there a phase shift here? No. So we skip straight to which one's next on the list? The period. Okay, good. So draw yourself a nice coordinate plane here. All right, here's mine. And what we're going to do is we're going to scale our x-axis according to our period. All right? So I happen to have 4 slots here because the cosine curve, right, gives me 5 things that I need to have total. So I'm going to put my 4 slots on there. And I know I need to start and end on a distance of how long? How long does that distance need to be? That needs to be pi over 3 units because my period is pi over 3. So I know pi over 3 is going to be happening right here. What's wrong? Where are the crayons? Oh, right up here. In front. So let me ask you a question. How do I scale this x-axis if I have to start and end on pi over 3? Yes? Divide pi over 3 by 4. That's right. So what would that give me? Pi over 12. So there's an easier way to do it. I kind of just do it like this, but it's the same idea. What's what's in between 0 and pi over 3? Pi over 6. What's in between 0 and pi over 6? Pi over 12. Now just start counting. 1 pi over 12, 2 pi over 12. So this has to be 3 pi over 12, which of course is pi over 4. Good. Now I need to go up and down to a height of 4, right? Because the amplitude is 4. So I'm going to call this 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. All right, so I'm going to pick a color. The first thing I have to do is the period. So I'll do that in black. So a cosine curve starts up here at 1, and it ends at 1. Halfway between, it's down at negative 1, and then the other 2 points, it's at 0. So I know that the black line represents y equals the cosine of 6x. So I give myself a little scale. Say, okay, the black one's the cosine of 6x. The next one is the red one. So we're going to make that 4 times the cosine of 6x. So now, do I move the entire graph up 4 units? No, I don't. I just scale the amplitude to 4 units, right? So that means that this part is an amplitude of 1 for right now. I need to scale it to 4. So I go 4 times the value of 1 gives me 4. But 4 times the value of 0 is still 0, and then down here, negative 4, 0, and then up there. So the end. Okay, so let's turn our calculators on. Make sure you're in radian mode to graph trig functions. Let's go to y equals, and let's punch in 4 times the cosine of 6x. So 4 cosine of 6x. So 6x. All right, now, what we need to do is change our window to match our graph. So we're going to go to the window, ask ourselves, what's the lowest x value we have? X value. 0, right? What's the highest x value we have? Pi over 3, second pi divided by 3. What's the scale we're choosing to use here? Pi over 12. We're going by increments of pi over 12. So second pi divided by 12s. What's the lowest y value we have? Negative 4. And of course the highest y value we have is 4. Now if we did this right, then the picture on our graph should match exactly the picture on our paper. And, of course, there it is, right? We can see that the first dot on our graph is at a 0, which represents pi over 12. So pi over 12 is at 0. And then all the way down the line matches perfectly. So what do you guys think? Easy, medium, or hard? Easy. Good. Okay, let's do a couple more, and then we'll be good on that. Let's do this one. Let's do 2 times the sine of pi x. 2 times the sine of pi x. So the 2, of course, tells me that the amplitude is equal to the absolute value of 2, which is just 2. And then the pi I use to get my period. That's a terrible looking period. So 2 pi divided by pi. The pi is canceled out, so I have a period of 2. Now, someone in the other class asked, what does that mean when you have a period of 2? So let me ask you guys that. How come there's no pi there? I'm like, what's going on? Daniel, what do you think? Since your hand's up. Never mind. Okay. Is that like 2 elephants? What is that? What is that? 2 units. It's still a radian, right? Even though there's no pi in it, that doesn't mean it's not a radian anymore. After all, right? Pi radians is 3.14, blah, 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 right? So we can have a 2 in there. We can have 2 radians. That's okay, too. So it's still a radian. It just doesn't have a pi in it. So don't get weirded out by that. Just deal with it. It's okay. You know, just treat it like, deal with it like, treat it like you would, you know, a regular radian. That didn't come out right. I didn't mean to be like that. Anyways, so so I have to start and end on a distance of 2 radians, right? So what's halfway between? This one's easy. 1 and then half. So 1 half 1, so this has to be 3 halves, right? So there's my scale according to my period, which is a distance of 2 radians. That's how long it takes to complete one full curve. Now I need to go up to 2 and down to 2 to adjust for my amplitude. Now since I'm dealing with a sine function, I know that the sine function is going to start and end at the x-intercepts. There's also another x-intercept. Where is it? For the sine curve. There's one at the beginning, the middle, the beginning, the end, and the middle. I'll just give it away. All right. Okay, a quarter of the way, we're up at 1, and then we're down here at negative 1. So this is your basic 5-dot sine curve. So that one, the one I have in black, would be the equation y equals the sine of pi x. That's my black curve. Then I get my next curve, which is 2 times the sine of pi x. So that means I'm going to increase my amplitude. This one stays there. This one goes up to an increase of 2, stays there, and then goes down to 2 and stays there. So, okay, so wherever you're at, take a look at mine. Since I had a negative 2, I had a reflection and an amplitude that's been shifted to or extended out to 2 units. My period was 4 pi because I took 2 pi divided by half, and that gave me a distance for the period of equal to 4 pi. So a full cycle takes a distance of 4 pi. So the end result is my blue graph. Does yours match what mine got? Did anybody graph it on their calculator and get it to match out perfectly? A couple people did. Okay, great. We're going to move on now, and we're going to do a big example. I have 2 big examples I want to do. This is the hardest one of the day right here. And this is going to require a lot of thinking on our part, or my part, or our parts. Can we go up for just like the second? Yes. Okay, first of all, let's write this one down. I've got the big examples, I'm calling this. Y equals 3 times the sine of 3x minus pi. All right, there are a few things happening here. Let's name the easy one first. What's the easy thing that you can see that's being done to the sine curve? The amplitude, the easy one, right? This one here, this 3, means I'm going to have an amplitude that's equal to 3. Got that part. Good. What else is going on? What's the period? Okay, let's talk about the phase shift. Yes, there is a shift. Can anyone guess as to which direction the shift is? Adrian. It's right, that's correct. By how much? By pi. And that's what everybody thinks. It's like the Matrix. Everybody falls the first time when they jump across from the buildings, right? You guys didn't catch that? No, this is, everybody thinks that it's pi units to the right, but it's not. It's not 1 either. What it is, here's the trick. See how your variable is being multiplied by 3? You got to free up your variable. Free the variable. Okay, so we're going to rewrite this whole equation that looks like this. Y equals 3 times the sine. I'm going to factor out of 3. Yeah, there it is, buddy. So x minus pi over 3. Now, where does the pi over 3 come from? Why is that there? Can we see it besides the 2 people? Okay, what's 3 times x? 3x, that's where that is. And now I have to take 3 times something, and it has to give me back pi. So it has to be pi over 3, okay? Now, this does a couple of things for you. It identifies the amplitude, which we already did. It tells me that the period is equal to 2 pi over 3. And it tells me that the phase shift is pi over 3 units.
That says 2 pi over 2.
Thanks. Pi over 3 units to the right. So the big idea on this one is whenever you have a coefficient in front of your variable, in those parentheses, free it out, and you can see exactly where the phase shift is and exactly what the period is, all right? So what we're going to do is we're going to graph this thing. And we're going to have to do a phase shift first, okay? So the phase shift means we're going to go pi over 3 units to the right, okay? So we're going to count by units of pi over 3. So there's a pi over 3. So this has to be 2 pi over 3. This has to be pi, because that would be 3 pi over 3. And then this has to be 4 pi over 3. And then this would have to be 5 pi over 3. Okay? Alright, so I'm going to have to go up to 1, 2, 3, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. Okay, so if I'm going to draw a sine curve that's been shifted over, pi over 3 units to the right, then I'd have a sine curve that would look something like this. That's pi over 3. So sine curve starts and ends here, right? Halfway looks like that, and then up looks like that, and then down kind of looks like this. Okay? So there's a sine curve that's been shifted over pi over 3 units. Okay, now I'm going to go take a look at my period here, okay? The period is telling me that it's 2 pi over 3. So where is, on my scale, 2 pi over 3 units? 2 pi over 3 radians. If I have to start here, where am I going to end? Not next to it, because that's only 1 pi over 3 over. Remember, each increment is an increment of pi over 3. So wouldn't it be there? Isn't that right there? Isn't this a distance of 2 pi over 3 radians? Isn't that 2 pi over 3 radians? So that was my period. So I need to start and end. Basically, I need to take my red graph and shrink it in, make it fit into my highlighted part. Crazy, huh? That's what the period is. So how do we do that? Okay, well, it's pretty straightforward. I know that I'm going to have to start here. I know I have to end here. I know I have a sine curve, so halfway between, I'm also going to be at 0. So that means that at this point and at this point, I'll be up here at 1, and I'll be down here at negative 1. The only thing is I just need to figure out what those points are. Alright, so what's halfway between 0 and pi over 3? Pi over 6, right? So that means that this part has to be pi over 6. This is 2 pi over 6. This is 3 pi over 6, which is just pi over 2, isn't it? Isn't 3 pi over 6 pi over 2? Okay, 4 pi over 6. So this one has to be 5 pi over 6. And then 6 pi over 6, of course, is still pi. So there's my scale that I've got it all worked out now. Only thing left to do is to increase the amplitude from 1 to 3. So I'm going to use, let's go gray. So that one stays there. Pi over 2 goes up to 3. This one stays there. This one goes down to 3. And this one stays there. So they're like a W. Okay, so let's take out our calculators and let's make sure that our window matches to make sure that we did it right. So I'm going to go and punch in the original function, which was 3 times the sine of 3x minus pi. You guys remember it? Seems like it was so long ago. Alright, I'm going to go there. I'm going to go to my window. My lowest is 0. My highest is that pi? Pi. And my scale is pi over 6. So second pi divided by 6. My lowest min is negative 3. My highest maximum for y is 3. I'm going to hit graph. And there we go. I definitely have matching that are happening to this thing. Alright, tell me, let's shout out. What is this thing going to do?
Vertical shift.
So, up 2. Good job. What's this thing going to do? Amplitude is equal to the absolute value of 3, which is 3. That's a terrible 3. What is this 2 going to do? Period. So 2 pi divided by 2 gives me a period equal to pi. Good. And what is this part going to do right here? Phase shift pi over 2 units to the left. There you go. So my arrow points left. So there's all 4 things that we're doing. Okay, lots to be done. So I'll bring this down. And here we go. Let's draw it out. Hopefully you guys use a ruler. In fact, I'm going to use a ruler because that looks terrible. Bam, bam. Okay, since our phase shift is in increments of pi over 2, we can keep everything the same. So there's pi over 2. That means that has to be pi. That means that has to be 3 pi over 2. And that has to be 2 pi. Just like we normally have it. That's negative pi over 2, and that's negative pi. That should be enough for now. And then I'm going to go 1, 2, 3, 4, 5, 6. So that's a 5. There's 3, there's 2, 1, 4, 6. I don't know why I ordered it like that. Okay, let's start off with a basic sine curve, right? In black, basic sine curve looks something like this. 5 dots. Here are my 5 beautiful dots. Hopefully yours looks better than mine. Okay, next, going down that list, I have to do what's the next thing to do? Phase shift. Good. So pi over 2 units to the left. Pick a different color. I'll go red. So I'm going to go pi over 2 units to the left. I didn't scale this appropriately. I can see right away. So let me do that before I mess up this whole thing. You guys yell at me. Okay, we're going to go pi over 2 to the left. So each dot gets moved pi over 2 units to the left. There is our phase shift. Okay, you guys with me so far? You mess up? Bummer. Okay, next thing, after phase shift we do what? Period. Now we have to start and end on a distance of what? Pi. So if I'm starting here, where's a distance of pi? At pi over 2. Good. All of that, the highlighted part there, that's a distance of pi, and that's what my period is, okay? So I need to shrink down my red graph, and I'll go blue now, onto that. So beginning and end, middle, half or a quarter of the way it's up, 3/4 of the way it's down. So see how fast and easy I shrunk that down to the correct period? After period, we do what? Amplitude. So I'm picking a different color. I'll go green. I'm going to increase my amplitude to 2 units. So this dot stays here. This dot comes up there. That one stays there. This dot goes down. That one stays there. Isn't the amplitude? Oh, bah humbug. You know what? I'm sorry. Totally messed that up. So let's go to 3. Sorry, team. So we'll go to 3. And down to 3. So it's a little bit bigger. Okay, there we go. Thank you for catching that mistake.
Up 2.
And then lastly, push all of those up 2. And I'm going to pick a really cool color here. Purple? Oh, yeah, there we go. So this dot goes up 1, 2 to there. This dot goes up 1, 2 to there. This dot comes here. This dot goes there. And this dot goes there. And then you have this beautiful purple